Hi, welcome back. So we are in chapter 2, Story of Math. In this chapter, we're going to discuss two major outlines. The first one, we will be looking at something related to the philosophy of math from a graphical representation. Then we will move on to another outline, that is the area of mathematics, by exploring a number of sub-outlines, cover the discussion of those areas. Let's go ahead and explore the first outline. So in this outline, we're going to discuss the philosophy of math. Let me introduce you first of all to the definition of math. Now, mathematics is an area of knowledge that includes topics of numbers, formulas and related structures, shapes and spaces, quantities and their changes. Now, these topics are represented in modern mathematics with the major disciplines of, for example, number theory, algebra, geometry, and analysis. In fact, there is no general consensus among mathematicians for their academic discipline. Now, perhaps the academic definition of math is easy to read. However, when it comes to applying mathematics to a real-life problem, then the struggle might emerge. And to this end, I wanted to share with you a graphical representation on the map of mathematics in a sense, or how do I really perceive the philosophy of understanding of mathematics. Mathematics, in fact, is a language just like any other language a human have invented over the time. English is a language, German, French, any other languages. So to this end, I'm going to use one of those analogies. In particular, I'm going to choose English as a language and make the example just in a comparison how the human language that we understand and we use on a daily basis is exactly similar to the understanding or the philosophy of mathematics as an independent language as well. And to do that, I'm going to start first of all by using two important categories in order to understand language in a sense. First, I'm going to start looking at language from pure perspective. Now, let's take English as the analogy that we would like to compare to mathematics. Essentially, to start to understand how a human actually evolved languages over the time, or spoken language over the time. First of all, you have to understand there were a number of systems or kind of pillars had been built one on top of the other in order to complete the comprehensive understanding on the language and how we use it. For example, if you look at the spoken language like English, first pillar or system, if you will, start with alphabetic system. Now, in the alphabet system, usually a human come up with the idea by creating a number of those alphabet and have a certain vowel and have a certain sound. For example, it could be in a form of capital letter, just like in English what we use at the moment, or in a small or little letter as the ABC, which we are using. A similar thing when it comes to mathematics, and this system starts with the system of numbers. So number system was the first or the essential starting point. And the number system essentially had different elements. For example, starting with the natural number. Discovered as well the integers, we discovered rational numbers, real numbers, and etc. So these are just exactly similar to the alphabetic of a normal spoken language. The second thing, we needed another system to use those elements. In a spoken language, we created, for example, a system of words categorized in the form of a noun or maybe a verb or maybe adjectives or whatsoever. So in the same thing happens in mathematics, and this is where the system of structures has emerged. Now, this system of a structure has a lot of departments to study and analyze the properties or the structure of those numbers. Essential seed of the system, which is equation. And then we needed departments to manage that. For example, starting with the department of algebra, linear algebra, or the non-linear algebra. Also, another department was looking for the group form or structure of these numbers. Another department perhaps was looking for the order. Another department was looking for the combinatory structure of these numbers, etc. Coming back to the analogy of spoken language, once the words was structured and understood by using those alphabetic, we needed another system now to organize these words in a certain form that can be meaningful. And this is where the system of a sentence was merged in spoken language, where the idea of a subject, a verb, and an object was put all together to create or structure a sentence. Same thing happens with the natural language of mathematics, where we needed another system to translate this structure into a tangible or something can be shaped and visualized. And this is where a system of space has emerged. Now, different departments emerge under this system to study or to manage or to analyze the property of those shapes. For example, Department of Geometry, Trigonometry, Fractal Geometry, for example. Maybe you've got differential geometry, etc. Now, finally, once the sentence was taken place and we understood how to create a sentence in a spoken language, we needed a last system that put all together to create a comprehensive image, including the emotional, the logic, the idea, the connection. And that is where the emerge of paragraphs, for example, system in a spoken language. Now, same thing in mathematics. We needed a last system to study the changes of those elements or shapes. Number of departments again had emerged. For example, you've got the departments of calculus, vector calculus, dynamic analysis, and so on. So basically, by the end, you could see that each one of those systems with their own departments have managed to administer, to introduce and purify the structure or the understanding of the language, just as a human language that evolved over the time. Now, once the language is established, you need kind of application for the language. And this is where the second category of looking at the language, which we call it the applied side. And from applied side perspective, I want you to think, once the language is in there, aren't there a number of countries or group of people, they are going to adopt the use of this language and they will follow the syntax and the structure of this language. And that's exactly what I mean with applied. For example, there are a number of countries have chosen this language to be their own first language to represent the existence of their entity. These countries or maybe group of people or even institutions have chosen this language to be the first language of communication. Same thing when we want to look at mathematics as an independent language, you will see certain disciplines or fields have found this language to explain the work that they are trying to do. For example, you got the physics discipline or departments. You got, for example, the field of chemistry. You get the field of biomathematics. You got the field of engineering, computer science, and many others. Now, if you try to perceive mathematics from this philosophical or graphical presentation, I believe the image of mathematics become way easier than ever to understand. So next we'll be looking at the outline to discuss area of mathematics. I will see you then.